Hi there, mathematicians. Let's get started with our trigonometric ratios. So our trigonometry section, second half of the chapter 9. We will start with the tangent ratio. Our lesson objectives are to use the tangent ratio, also to solve real-life problems involving the ratio. So our essential questions are: how is a right triangle used to find the tangent of an acute angle? And is there a unique right triangle that must be used? All right, here's a little history on trigonometry. The father of trigonometry, known as Hipparchus, was around 190 BC to 120 BC, so a very long time ago, but he was a Greek astronomer, geographer, and great mathematician. So I don't want us to be intimidated by this word trigonometry. It's simply from the Greek trigonon, which is triangle, and metron, which is measure. So it's the branch of mathematics that deals with the relations between sides and angles of a plane or spherical triangle. So our calculations are based on them. So it's simply dealing with the measure of triangles. All right, let's start off with some important terms that we need to know. Ratio, which we've already been using. Again, it's the comparison of two things, usually written as a fraction, so some number divided by another number. So now we put this adjective new word, trigonometric ratio. It's used to find the measure of a missing side length or a missing angle in a triangle. And we have these 6 abbreviations that we must remember. Our 3 trig ratios are tangent, sine, and cosine. Tangent shortens down to TAN, so an abbreviation for tangent is TAN. Sine is abbreviated SIN. Please do not say sin when you see SIN. It is sine. And then you have cosine, which is abbreviated COS. And then within the ratio, so when you compare the number to another number, you'll see 2 of these as either your top number, numerator, or denominator. So opposite leg shortens down to OPP, adjacent leg shortens down to ADJ, and hypotenuse shortens to HYP. So depending on which angle you're identifying, you would look across to identify its opposite. So if this is the acute angle of the right triangle that you're going to use and figure out, then you would have this side as your opposite and this side as your adjacent. Hypotenuse never changes. It's always going to be the hypotenuse, the longest side, which is directly across from the 90-degree angle. It's the opposite and adjacent that switch depending on which acute angle you're looking at. And if you're wondering what this little funny looking symbol looks here in the triangle is or represents, it simply represents an angle. It's the theta sign. So trig ratios compare 2 sides of a right triangle. Every angle, in other words theta, has a specific trig ratio. All right, trig ratios comparing 2 sides of a right triangle, and every angle has a specific trig ratio, as I said before. So our first core concept is the tangent ratio. So let's get more familiar with our tangent ratio. So let triangle ABC be a right triangle with acute angle A. The tangent of angle A, written as, and remember, shortened abbreviation for tangent is TAN, and then we're talking about angle A, so we can shorten that down to TAN A, is defined as follows. Given triangle ABC here, we want tangent of A. So if angle A is here, and there's our theta sign once again, it will be the ratio, in other words fraction, of opposite leg, so the entire length of leg opposite angle A, divided by the length of the leg adjacent to angle A. In other words, the ratio of side BC length divided by the length of AC. So if we shorten this down to all abbreviations, we can say the tangent of theta, our angle, is equal to opposite divided by adjacent. And to help us remember, we have some letters to shorten it down to, so TOA, and that's pronounced TOA. And just another reminder, our symbol for the angle is the Greek letter theta, and it simply represents an angle measure. All right, so let's find the tangent ratio of the following example. We're going to find the tangent of S and tangent of angle R. Write each answer as a fraction and as a decimal rounded to the thousandths place. In other words, 4 place values. So let's start with tangent of angle S. So here we are, here's our angle. So tangent is always opposite divided by adjacent, all the time. So if here's the angle, then I identify my angle that I'm trying to get the measure of, and then I go to the opposite side divided by adjacent. So I want 80 divided by 18. So when I type that in the calculator, I get a decimal value of 4 decimal and then 4 repeating, and since it asks for it to be 4 place values, so the thousandths place, then I stop at the 4th 4. The simplified fraction would be 49ths. All right, next we want the tangent of angle R. So again, find the angle, here it is. We want opposite divided by adjacent. So this time we want 18 divided by 80. And that simplifies down to 9/40 as a fraction. And then type 9/40 in the calculator and you get a decimal of decimal 2250. So tangent of angle S is 4.4444, and tangent of angle R is 9/40, which simplifies to, or converts to decimal 2250 as a decimal. Now those were ratios. Now let's take a look at how we would calculate angles of our trig ratios. So this is where we need to look at our calculator. So grab your calculator and find the trig button. Then select the trig function from the menu that you want to use to calculate the angle. So once you hit your trig button, which is located just next to the 7, so to the left of your 7 key, hit that trig and it opens up this menu of all our different options for our trig ratios. Right now we're focused on tangent, so you would pick TAN, which is the abbreviation for tangent. And then on the screen next, you should see a parentheses with the cursor. And then whatever angle you're looking at, you type in that angle measure. So go ahead and just practice with tangent of 32. Type in 32, hit enter, and see if you get the same decimal values as you see here on the screen. So we'll definitely need to know, be able to use this feature on our calculators. All right, we want to find the value of x. So this time we're finding a leg length. We're given the angle measure, we now want to find a missing leg. Now this isn't one of our special rights, and we can't use Pythagorean theorem here, so we have to use our trig ratios. And since we have an opposite length, because this is our angle, angle 32 is our theta, so we have an opposite identified length, and then we have an adjacent unknown that we're trying to figure out. So because we have an opposite and an adjacent, we would have to use tangent. So we're finding the tangent of an acute angle to find the leg length. So our first step is to write our equation. And you start by writing tangent and then whatever the angle is that we're identifying or using, in this case it's 32, equals, and then we abbreviate opposite divided by adjacent. Next we want to substitute what we know and what we don't know, what we're trying to figure out, in this case x. So we substitute 11 for opposite and x for adjacent. Now just like we would solve any other equation, when x is in the denominator, we would multiply both sides by x, which is what happened here on this step. We multiplied this side by x, and we're also multiplying this side by x, which is how we got the x's to divide each other out, leaving us with this next step of x times tangent of 32 equal to 11. So next we have x times the number that is tangent 32 degrees. And if you remember on the previous screen, we saw that tangent 32 was a decimal value. So please think of your tangents, your cosines, and your sine of angle measures as actual numbers, like values. So if we realize that, we know that we're going to have to divide both sides by tangent 32. to get x by itself. Which is why on this next step, x equals, because the tangent 32s divide each other out, we have x by itself equal to 11 divided by tangent 32. So when you use your calculator and divide 11 by, and use your tangent key, tangent 32, then you should get a decimal value of about 17.6. So the value of x is about 17.6. All right, our next example, you can find the tangent of an acute angle measuring 30 degrees, 45 degrees, or 60 degrees by applying what you know about special right triangles. So let's use a special right triangle to find the tangent. So use a special right triangle to find the tangent of a 60-degree angle. Well, let's just use a general 30-60-degree angle right triangle with shortest length being 1. Therefore, the longer leg would be square root of 3. And using our special formulas that we developed in the previous section, we know that a longer leg equals the shorter leg times square root of 3. And if we're saying that our shorter leg is 1, then we multiply 1 times square root of 3, then our longer leg is square root of 3. Now, if we were to find the tangent of the 60-degree angle, we would set up our equation, so tangent of 60 degrees equals opposite divided by adjacent. And if we identify our 60-degree angle here, then opposite would be square root of 3 divided by adjacent, which would be 1. So we get tangent of 60 degrees equals square root of 3 divided by 1. Well, anything divided by 1 is itself. So this simplifies down to tangent of 60 degrees equals square root of 3. So the tangent of any 60-degree angle is square root of 3, which approximates to 1.7321. All right, let's take a look at some real-life problems. And before we do that, let's establish some new vocabulary, angle of elevation. All right, angle of elevation, think of looking upward. When your elevator kind of going up, escalator kind of going up. So an angle of elevation is the angle that an upward line of sight makes with a horizontal line. So here's a great picture to illustrate what this definition is saying. Your horizontal line is here, so it's kind of parallel to the ground. So whatever your line of sight is from the observer looking up at an object, that angle made between the line of sight and the horizontal line is called an angle of elevation. So looking up, think up for elevation. Now let's take a look at this example. You're measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height h of the tree to the nearest foot. So we know this is a tangent ratio, so tangent of 59, so the angle of elevation of 59 equals opposite divided by adjacent. So we fill in h divided by 45, multiply both sides by 45, and type this in your calculator. So 45, then tangent 59, hit enter, and you get 74.9 for the height. So the tree is about 75 feet tall. All right, that's all for our tangent ratios. And how can you resist this face? All right, see you in class.